Hey, Chemistry 12 class. Quarantined Chemistry 12 class. We have a Chapter 3 test that you're going to be doing. So this week we're going to be working on studying for that Chapter 3 test. So here I have the Unit 3 practice test. And this will be a good way to get ready for your Unit 3 test that's through Microsoft Teams. Anyways, do this. Make sure you understand it. If you don't understand everything here, then message me before you write the test. You can also download this practice test from Microsoft Teams so you can see and try to do it. So try doing this test first and then check your answers back here. Anyways, you need to have your data booklet, so make sure you have that. I have mine right here, and I'll refer to it periodically. Okay. Which of the following is a suitable term for representing solubility? We talked about that before we went before spring break, and essentially it is concentration. So the only one that's concentration is this one right here. Okay. Another way you can think of it too as Ksp, which stands for the SP part stands for solubility product, and Ksp equals, well, it's whatever the concentrations of the products are. So here's a product and here's a product right here. And remember that these numbers right here have to be reported as molarity. Okay, so solubility needs to be reported as molarity. Number two, a saturated solution is prepared by dissolving a salt in water. Which of the following could represent the ion concentrations as the temperature is changed? It doesn't tell you if the temperature increases or decreases, but let's just kind of draw any kind of salt in water. So we'll just say like AB turns into A plus B minus. So if the temperature, say, increases and there is a shift to the right, that means A is going to increase and B is also going to increase. If there's a temperature change and it's cooled down and there's a shift to the left, then that means A is going to decrease and B is also going to decrease. So the important thing to understand here is that if A increases, B also increases. Or if A decreases, B also decreases. And what we see when we go here is we see this one right here is increasing and this one is decreasing. So we know it's not this answer. Same thing for right here. It's one is increasing and the other one is decreasing. So we know it's not that answer. Same thing for this one right here. This one is decreasing. This one is increasing. This is not the right answer. And here they're both increasing. This one is the right answer. What is the concentration of OH minus ions in 250 mils of solution of 0.2 molar SrOH2 solution? So first I'm going to write a kind of a equation right here. And it's going to be Sr2 plus OH minus. Since there is a 2 here, we need to balance this reaction by placing a 2 in the front right here. Now, if this is a 0.20 molar solution, it is a 1:1:2 ratio. I know we didn't learn this in our Microsoft Teams. It's because we learned all about this before spring break. So if this is a 1:1:2 ratio, then that means the concentration of this thing is going to be 0.20 molar, and the concentration of this one is going to be twice as much. It's going to be 0.40 molar. This number right here was completely to distract you. Okay, so the concentration of this one is right there. What happens when 10 mils of 0.2 molar KOH is added to 10 mils of 0.2 molar KuSO4? So in other words, like all precipitate kind of things, it's just going to be a double replacement reaction. So I'm just going to write KOH plus CuSO4. These 10 mil things are kind of useless information. The 0.2 molar thing is kind of useless information. The only point of having that information is that when you have equal volumes, that's equal volumes, and you have zero point 0.2 concentrations, after you do your dilution, it'll work out to a 0.1 molar uh, concentration, and that's that's important to know because on this table right here, it says that hey, all these kinds of things right here are all about 0.1 molar concentrations. So that's the only reason they gave you those numbers, but you don't have to do any kind of calculation with those numbers right there. So again, we have our this and this. We're going to do our double replacement reaction. So it's going to be K2SO4. SO4 is 2 minus, and plus Cu bracket OH bracket 2. Let's take a look at these two different things right here. So let's take a look at K2SO4 to see if it forms a precipitate. So we're going to open this thing up and we're going to take a look at K2SO4. So here is SO4, and K, which is not part of here, it's part of all others, is soluble. So that means no precipitate. So here for this one is no PPT, no precipitate. Now let's take a look at CuOH. Oops, not this one. There we go. So we have OH. Only these ones right here is going to be soluble. Copper is part of all others, and that's going to be low soluble. So in other words, that's going to be a precipitate. Okay. So this is going to be our answer right here. Precipitate of CuOH2 forms. Okay, next question. Solid NaCl is added to a AgCl solution. So first, AgCl is not very soluble. And we can tell that through our table right here. AgCl, not very soluble, so it's going to form a precipitate. So anyways, just to show you, it's going to be AgCl, Ag plus Cl minus, like that. Now, it's asking what is going to happen when you add a bunch of NaCl to this. So first off, Na is just going to be a spectator. Okay, so if you add some NaCl to this, it's going to increase the concentration of Cl. And that means it's going to, since it increases the concentration of Cl, it forces this thing to shift to the left. Okay, now when this shifts to the left, what is going to happen to the concentration of Ag? Well, Ag plus is going to turn into AgCl. So that means it is going to decrease. So we know the answer is going to be either B or D. Now, here is the tricky part, I guess. So if we have NaCl is added to a saturated solution, how had the Ag and Cl changed when an equilibrium has been re-established? So if I was to draw like a chapter 2 graph, like a Le Chatelier graph, this would be my graph. So imagine here's our Ag. It shifts to the left, so therefore Ag is going to decrease like this. Okay, here's my Cl. Okay. We added a whole bunch of Cl, so it's going to spike, and then it's also going to shift to the left. Okay, so it also goes down right there. But there's an overall gain from this point to this point. So it did go up and then go down, but overall, from the first equilibrium at this point to the second equilibrium, it has increased. Okay. Um, so Ag is decreased overall, and chlorine has increased overall. Okay. Um, Kind of a different kind of question here. Which of the following expressions represents the concentration of Fe3 plus in the saturated solution of iron 3 hydroxide? So first I'm going to write this out. FeOH3 turns into Fe3 plus OH minus. This is not balanced. There's a 3 right there, so that means that I need to put a 3 right here. So if I was to come up with a Ksp expression for this thing, it'd be Ksp equals the concentration of Fe3 plus times the concentration of OH minus. And since we have that 3 right there, we need to put a cubed at that point right there. Okay, so now we have our Ksp expression right here. But the question is asking which of the following expressions represents Fe3 plus in this. So in other words, what that whole sentence right here means is that rearrange this formula, please, so that it says the concentration of Fe3 plus equals something. What exactly does it equal? So we just need to do some math on this and move a few things around. So how you do that is you have Ksp right here. So I want to isolate this Fe3 plus. So I'm going to divide both sides by this OH minus. Now I can't just divide by one OH minus. There's kind of like 3 of them right here. So I need to divide by all 3 of these things, or cube it. So what that means, change my pen color, is that these things, or sorry, actually before I do anything, is that, again, some basic math. If I do that to one side, I must do that to the other side to make it equal. So I'm going to go do that to this side right here, OH minus to the power of 3. And then if I do that to one side, you do it to the other, this cancels out right here. And then that means I'm left with Ksp over concentration of OH minus 3 equals concentration of Fe3 plus. So my answer is this thing right here, Ksp over OH minus to the power of 3. Which one of these things says that? There it is. Okay. What is the value of the Ksp for zinc hydroxide if the solubility of this thing is 4.2 times 10 to the minus 6? So Zn bracket OH2. So first I'm going to write my formula, Zn2 plus OH minus. This is not balanced because of that 2 right there, so I need to place that 2 right here. So if I write my Ksp expression, Ksp equals the concentration of Zn2 plus times the concentration of OH minus. Since there's that 2 right there, I need to square this right here. Okay. Now, it says this is a 1 to 1 to 2 ratio. So it says the concentration of zinc hydroxide is 4.2 times 10 to the minus 6. So that means the concentration of zinc, since it's 1 to 1 right here, is also 4.2 times 10 to the minus 6. And the concentration of OH is twice as much. And I could do that multiplication in my head. So 4.2 times 2 is 8.4 times 10 to the minus 6. So Ksp is going to equal, well, the concentration of zinc, which happens to be 4.2 times 10 to the minus 6 times 8.4 times 10 to the minus 6 squared. Okay. So I'm going to plug that into my calculator. I'm going to go 8.4 times 10 to the minus 6 squared equals 7.056 times 10 to the minus 11. And I have to multiply that. So times by 4.2 times 10 to the minus 6 equals, and I get 2.96. I ran out of room here, so I'm just going to write up my answer up here. So Ksp equals 2.964 times 10 to the minus 16 times 10 to the minus 16. So that's my answer right here. Now, obviously, we don't see that answer for here, but and that's because they rounded it. So this would round to 2 sig figs because this is 2 sig figs. So this would be 3.0 times 10 to the minus 16. That's my answer. Okay. What is the maximum number of moles of chlorine that can exist in 500 milliliters of 2.0 molar AgNO3? Okay. So first off, this NO3 is a spectator. If you can't remember that, NO3 is just like always a spectator. So NO3 with everything is soluble. So that means it's never going to form or precipitate with anything right here. So essentially what we're dealing with is AgCl and forms an equilibrium with Ag plus Cl minus. Now, the Ag plus concentration came from this AgNO3, and that concentration was 2.0 molar. Okay, and it's saying, well, if this is 2.0 molar, what is the concentration of chlorine, which is X? So if I was to make a Ksp expression, it'd be Ksp equals concentration of Ag plus times the concentration of Cl minus. Ksp, we don't know that unless we go down to here. So we go to here and we find where is silver chloride, which is 1.8 times 10 to the minus 10. So now that I have my 1.8 times 10 to the minus 10, I memorize that. Go back here and I type in 1.8 times 10 to the minus 10 equals. And that is going to equal to our concentration of Ag, which is 2 molar, times the concentration of Cl minus. And that's what we want to figure out. So I'm going to type into my calculator 1.8 times 10 to the minus 10 divided by 2. Okay, so I'm dividing by 2 on both sides. And what I get is I get 9 times 10 to the minus 11. And that equals the concentration of Cl minus. Okay, now this is where the question gets tricky, because we obviously see that answer right here, and a lot of people are going to be circling it right away. But the question doesn't say what is the concentration of chlorine. It says how many moles of chlorine can there be. Okay, and that's why they threw in that 9 times 10 to the minus 11 right there. So this is concentration. So 9.0 times 10 to the minus 11 is the moles per liter. We don't want moles per liter. We want the number of moles of this thing. So I need to times this by how many liters we have, which is 500 mils, or in other words, 0.5 liters, like that. Then that will cancel out these liters, and then we will be left with the number of moles. Okay, so we take this number, we times it by 0.5, so times by 0.5, because that's how many liters we have, and we get the number 4.5 times 10 to the minus 11 moles. Okay, again, the question wants moles. This should be like a 2-mark question, and it's an old provincial exam, and some of the questions, they actually, for the multiple choice, they actually did make 2 marks, and some of them they made only 1 mark. But anyways, this is 4.5, so our answer is this one right here. Okay, a little bit tricky because we have that distractor in here. Okay, which of the following will dissolve in water to form an ionic solution? Essentially, which one of these things is ionic? In other words, having a positive ion and a negative ion. Well, no. This is, a lot of people want to say that like this is a base, right? This is not a base. This is methanol. This is alcohol, a type of alcohol. This is covalent. That's a covalent bond. This is methane. That's a covalent bond as well. And this is oxygen. And technically speaking, oxygen gas, O2, those are sharing electrons. That's covalently bonded as well. This is the only one that's ionic. If you remember before spring break, I took a light bulb and we stuck it into sugary water, and the light bulb wouldn't light up when we ran electricity through it, and then I put in a whole bunch of other types of covalently bonded compounds into the water, and the light bulb wouldn't light up. But as soon as I threw in an ionic bond, it lit up, and ionic bonds can conduct electricity. Anyways, the positive part in this thing is the NH4 plus, and the negative part is the Cl minus. Okay, the solubility of this thing is this. How many moles of dissolved solute are present in 100 mils of saturated kind of SrCO3 solution? Okay, well, this is a chemistry 11 kind of question, and yeah, so we're just figuring out changing molarity into moles. So 2.4 times 10 to the minus 5 moles per liter, and I'm going to times this by our liters, which is 100 mils, or in other words, 0.1000 liters. So 0.1 liters cancels out, and then we're left with 2.4 times 10 to the minus 6. Okay. So nothing super tricky about that. I think a lot of people, when they kind of do this, will be definitely overreading it and kind of thinking about it a little bit too much. So we'll go on to this next one right here. What is the ion concentration of this one of 0.3 CuCl2? We did this before spring break, and I've talked about this already in previous questions. If this thing completely dissolves, actually, it would be just kind of like that. Actually, I should write 2 plus. This is not a balanced equation because of that 2 right there. So I need to place a 2 right here. So again, if this is 0.30 molar, this right here is going to be, since it's 1 to 1 to 2 ratio, this is going to be 0.30 molar. And that means this is going to be 0.60 molar. Okay. So anyways, that answers the question right there. Cu is, and Cl is that one. So the answer is here. Okay. What is the net ionic equation for the reaction that occurs when equal volumes of these things here? Now remember, the word net ionic equation, we also learned this before spring break, means you get rid of the spectators. So we have these numbers are irrelevant. It just means that a precipitate will form if it has low solubility. BaNO3 2 plus Na2SO4. So right away, we talked about like Na is almost always used as kind of a carrier ion or a spectator ion to carry something in there, and we know that because Na combined with everything is soluble. So Na is going to be soluble. That's a spectator right there. The other spectator as well, and we've talked about that one a few times, is this NO3. NO3 plus everything is soluble as well. Okay, so so this one is soluble as well. So the question is that does Ba and SO4 create a precipitate? If it doesn't create a precipitate, then there will be no answers because there'll be no reaction essentially. So we have to look up Ba and SO4 just to make sure. And what we see is that Ba 2 plus SO4 2 minus does create a precipitate. It says low solubility. So we know that that one's going to be our thing right there. So when Ba 2 plus is added to SO4 2 minus, it'll create precipitate that says BaSO4. Remember, swap, like these will cancel out, so you don't have to have any subscript numbers right there. So anyways, which one's the answer? It's going to be this one. Okay, a few crystals of Na, again, spectator ion. IO3 are added to the above equilibrium. How do the new ion concentrations compare? So in other words, what we're doing is we're adding IO3 to this concentration. This is going to go up. It's going to be shifting to this way. Okay. Since a bunch of AgIO3 is going to be made, what's going to happen to the Ag concentration? Well, it's going to decrease. Now, we had an exact same question earlier, but if here was my Ag concentration, it shifts left, it's going to decrease like that. Okay. So here's our Le Chatelier graph, and we added IO3 minus. Okay. And so here is our iodate, IO3 minus. We added IO3 minus, so therefore it's going to be a spike in the graph, but it's also going to be shifting in that direction right there. But overall, it did increase Okay, so overall it did increase because, and the question says, how do the new ion concentrations compare with the original? So it increased and then decreased, but overall it did go up. So we have to say that's an increase. What is the Ksp expression for this thing? So ZnOH2 turns into plus OH minus. This is not balanced. Again, it's not balanced because we have that 2 right there. So we need to balance this equation by placing that 2 right here. So again, Ksp equals, this is a solid, this does not go into our expression. So it equals our concentration of Zn2 plus our concentration of OH minus. You don't put those 2's in front right here. What happens with that 2, remember, is that it turns into a square right there. So this is our Ksp expression. Okay, this, again, that's why this one is wrong right here. It puts that 2 in front. The concentration might be twice as, the concentration of OH might be twice as much as Zn, but this 2 does not go into the expression. Okay. The solubility of cadmium 2 carbonate is 2.5 times 10 to the minus 6. Calculate the Ksp value for CdCO3. So we're going to write CdCO3, and it turns into CD2 plus CO3 2 minus. This is already balanced. It's a 1-to-1 to 1 ratio, so we don't have to do anything. So that means if this is 2.5 times 10 to the minus 6, that the concentration of this is also 2.5 times 10 to the minus 6. And this is 2.5 times 10 to the minus 6. So my Ksp expression doesn't have any exponents because since it's 1-to-1 ratio. And so we can just plug in some of these numbers and go 2.5 times 10 to the minus 6 times 2.5 times 10 to the minus 6. Get my calculator out. I kind of can already see the answer because there's only one that says minus 12 on it. So 2.5 times 10 to the minus 6 times 2.5 times 10 to the minus 6. And I got 6.25 times 10 to the minus 12. Okay, so that's my answer right there. That's my answer right there. Okay. Okay. Number 16, at 25 degrees, what is the concentration of Cl in a saturated solution? It doesn't give you one number except that 25. And that number 25 is kind of just like, I'm not going to say it's a useless number, but it's kind of a reminder to say, check the table. And that's all that's really saying is that 25 degrees. Because when we talk about Ksp, all these Ksp numbers are given to us at a temperature of 25 degrees, including these ones right here. Okay, so when it says 25 degrees, it's not like you use that for a calculation number. It just means like, hey, you can use your table on this one, and you should be using your table. So we're looking for PbCl2, so let's go back to our table and look that up. So for PbCl2, there it is. 1.2 times 10 to the negative 5. So 1.2 times 10 to the negative 5 is the Ksp for this thing. Okay, and so if I write PbCl2 Pb2 plus Cl minus. Here's my equation, I guess, or not my equation, but my formula, I guess. But one thing again that's very, very important is that it's not balanced. We have that 2 right there, so that means this 2 needs to be right there. Now it's a balanced equation. So now I'm going to make my Ksp expression. So my Ksp equals the concentration of Pb2 plus, a little bit messy, looks like it says 3, but trust me, it says 2, times the concentration of Cl minus. Since we have that 2 right here, we need to write a squared right there. Okay. Now, it's asking what is the concentration of that Cl minus, and we don't really have anything else out. But what it's going to be is that if we had PbCl2, it's going to be a 1:1 to 2 ratio. So this is going to be we don't know the concentration of PbCl2, so it's going to be an X to X to 2X ratio. Okay. So I might write some stuff down here. So, but it's going to be an X to X to 2X ratio. I know that seems a little weird, but Ksp, I'm just going to kind of write some numbers in here. So Ksp is going to be 1.2 times 10 to the minus 5. We got that from our table, from our data booklet right here. Okay, so it's 1.2 times 10 to the negative 5, and that's going to equal, we don't know what the concentration of Pb is, so I'm just going to write X. Okay, we don't know the concentration of our Cl minus right here. We just know that it's twice as much as Pb. So I'm going to write 2X. Okay, so I know I said like before you don't normally write it 2 right here, but it's kind of more like we know that the concentration of chlorine is going to be twice as much as the concentration of lead. Now there is this concentration of chlorine is squared. Okay, so now I'm going to do some math to figure this whole thing out. So this is going to be 1.2 times 10 to the negative 5. Now that's going to equal 2x times 2x times x. So it's going to be x times 2x times 2x. Now, because 2x squared is the same as writing 2x times 2x. 1.2 times 10 to the negative 5 equals x. Now I'm going to multiply these two together, 2x times 2x. So that's going to be 4x squared. This is a really common mistake where people will go, okay, 2x squared, 2x, and then on the outside is squared. Oh, that's just going to be 2x squared. But it's not. You actually have to multiply those twos together. So it'll be 4x squared. And so it'll be, and then I'm going to multiply that x in there, 1.2 times 10 to the minus 5 equals, so x times 4x squared will be 4x cubed. Okay, now I'm kind of like taking a lot of room up for this question, but I'm going to divide both sides by 4. And that's going to cancel this out. So then I'm going to have 1.2 to the power of negative 5 divided by 4 equals, and it's going to be 3 times 10 to the negative 6. And that's going to equal x cubed. Okay. So now I need to take the cube root of this. If you can find, most scientific calculators will have a button that looks like this. right? And you can push that button to take the cube root of both sides. If yours doesn't have that, you can also do to the power of 1 over 3. That's the same as taking cube root. But anyways, I'm going to go 3 times 10 to the minus 6. And since I did it on that side, that's just going to be x. So we're going to go, oops, syntax error. So I'm going to go the cube root of 3 times 10 to the minus 6. And that equals 0.0144 equals x. Okay. There's a lot of math on that one. 0.0144 equals x. And we see that answer right here. And people are just going to be like, oh, I finally found an answer that matches up there. That's x. Okay. In other words, that's the concentration of Pb. The concentration of chlorine is 2x. So I need to take this 0.0144 right here and times that by 2 because it's twice as much. Okay, and I get the answer 0.0288. That's my answer. 0.0288. 0.0288. If I put that in scientific notation, move the decimal over 2 spots, it'll be 2.88 times 10 to the negative 2, or in other words, 2.9. That was a mathy question, but that's how you do it. It's not that bad, actually. Okay. Last question. That goes for all the question above. A 300 ml sample of saturated solution of silver sulfate was heated in an evaporating dish until all the water was evaporated. So in other words, it figured out how much silver sulfate was in the thing. And here's all the data. Calculate the Ksp of this thing. So first off, Ag2SO4 Ag plus SO4 2 minus. This is a not balanced equation because we have that 2 right there. So I'm going to balance it by placing a 2 right here. So it's a 1 to 2 to 1 ratio. Now, all this data is just like a really long way of making us find out what is the concentration of all this kind of stuff. So first off, let's find out how many grams there are. So if I take this number right here and I subtract it away from the evaporating dish, okay, so if I subtract these two numbers, then in other words, we subtract these, then you'll just be having solid AgSO4, Ag2SO4, sorry. So Ag2SO4. I'm just going to take these two numbers and quickly subtract them. So I'm going to go 32.26 minus 32.125, and that equals 0.135. That's how many grams of Ag2SO4. Okay, I still didn't find out the concentration of Ag2SO4, so I need to turn this into moles. So I have 0.135 grams of Ag2SO4, and I'm going to find out what the molar mass is of this stuff. So Ag2SO4, I do have a periodic table here, way up here. Ag2, so it's going to be 107.9 times 2. plus S. So plus 32.1. I'm doing this in my calculator, by the way. Plus 04. 16 times 4 is 64. So plus 64 equals 311.9 is the number I got. Hopefully I didn't make a mistake. I made a mistake on one of the last ones, and one student pointed that out and really let me know that I made a mistake. So I'm going to do this again. 107.9 times 2 plus 32.1 plus 64 equals, hopefully that's right. Okay. So anyways, this is the amount of moles of silver sulfate there is. So I'm going to go 0.135 divided by 311.9 equals, and I get 4.328 times 10 to the minus 4. That's how many moles I have. Now to find out how much, what my molarity is, I'm going to take this number, 4.328 times 10 to the negative 4 moles, divide by my number of liters, 0.03000 liters. And so I'm going to divide by that. Divide by 0.03 equals, and I get a concentration of 0.0144. I kept a whole bunch of sig figs just to make sure that my answer is a little bit more accurate, and I'll kind of like get it down a little bit further later. Anyways, here's my the molarity of this stuff. So this is going to be 0.0144428 molarity. Since this is a 1 to 2 to 1 ratio, this number is going to be the same. So it's going to be also 0.0144428 molarity. This value right here is going to be twice as much. So times 2 equals 0.02885 molarity. Okay. Okay. Still not done yet. We have to find the Ksp of this thing. So when we find the Ksp of this, Ksp equals the concentration of Ag times the concentration of SO4 2 minus. Now, since Ag has that 2 in front right here, then that means this Ag right here has to be squared. Okay, so Ksp equals 0.02885 squared times the concentration of 0.0144428. Plug that into my calculator, and I should have my Ksp. So I'm going to square this number here, equals times 0.0144428 equals, and I get 1.22 times 10 to the negative 5. Okay. And yeah, so that's essentially my answer. That's how I found out Ksp for this thing. Okay. Hopefully that makes sense. And if you don't understand something, send me a message, and we can go over what you don't understand, or if you want to do some other practices. But make sure you understand this before you write your Unit 3 test. Okay. Anyways, good luck.